And we're already recording, so I will just jump right in. This is the Digital Extended Specimen discussion session. Thank you so much for joining us. Thank you, speakers, for joining us. Thank you, audience members, for joining us. I'm looking forward to the two parts of today's session, which will be first hearing from some folks who are doing it, who are working in this realm of linking all kinds of specimen data in cool ways and with cool applications. And then we're going to spend the remaining time in a discussion. So these talks are each going to be about 10 minutes in length. We have Katja Seltman kicking it off with a video, and then the rest of the speakers will be live. And so if you have questions, please feel free to put them in the Q&A box. If time allows, and there's some time in between talks, we can jump into maybe some of the shorter questions. Otherwise, I think most of the questions we will, if they're kind of more discussion oriented, we'll reserve those for the end of our session here. So without further ado, I will go ahead and play Katja's video. And then the order of speakers will be Katja Seltman, Julie Allen, Abby Benson, and Ed Gilbert. So we will proceed accordingly. All right, I'm going to launch into Katja's talk here.
Hello, everyone. My name is Katja Seltman from the University of California, Santa Barbara.
Libby, when you muted the
Extended specimen from wearing the hat, both as a biologist who researches bees and as a lead PI of the Big Bee Thematic Collection Network. So the concept of the extended specimen conveys a current perspective of the biodiversity specimen as extending beyond the singular physical object to potentially limit this other additional preparations or digital resources. This is not considered a new concept, but it is an important concept for our community to consider how this is happening now and how it can be supported. It's kind of something we're coming back around to, I would say. We are already doing this. The extended specimen was obvious in the California Phenology Thematic Collection Network with their trait work, the Parasite Tracker, TCN, also with biotic interaction. So here we have a diagram of what is thought of as the extended specimen, from the physical specimen to the primary digital record, secondary extensions such as morphological and ecological data, and tertiary extensions such as biotic interactions. But I would also like to include data sets. So I would suggest another extension. This should include data sets that contain specimens and new sampling data sets that are inspired by specimens. Basically, the examination of specimens and collections creates initiatives or investigations to recombine and resample, thus extending the specimen. Again, not a new concept. So in the Big Bee project, though, we're creating some examples of this that potentially could be used as a model or moving forward. We are working on sharing both image and trait data sets packaged together in ways that we think would be valuable. An example of an image data set would be all the images that went into creation of a single photogrammetry model. An example of a trait data set would be all bee interaction records recovered from museum specimens. So how are we thinking about this? So our collections are generating data, and this data is shared to many data indexers and data portals, including iDigBio and GBIF. Also the bee library, which is the Big Bee Symbiota portal about bees, global biotic interactions, GloBee, and then from these index data sets, the data is transformed almost always in some way, either by aligning taxon names or filling out fields that weren't filled out, such as country or continent. And so it's this transformed data that researchers typically download. Or they acquire data from these aggregators. So from here, data sets are downloaded, and we are doing the same thing. So in the bee library, we're adding trait data, so value added, again, transforming the data. And this is going into summary data sets, as well as data coming from global biotic interactions or our global bee interaction data set. And these data sets are opinionated, which means that there's taxon name alignment, there's quality control. The key and critical point is that they have some kind of identifiers that can link back to the original specimens, such as a catalog number, but they also generate a DOI, document object identifier, that then can be linked back to the specimen. But we could do a little bit better, potentially. Big B is also working towards uniquely identifying data sets and its content using hashing. A hash is a unique string of numbers and letters that represents something, some object, digital object. In this case, we are using hashes to represent images. In this example, it can but it also can represent individual records, whole data sets, and other bits of information. They are unique identifiers generated from the properties of the object, not something that's assigned to them. And that's what makes them a little bit different. Hashing data is a common practice in computer science, and examples include cryptography, compression, checksum generation, and data indexing. What it gives us is the ability to create reference versions of our opinionated data sets and the specific that they contain. It is also helpful to validate the data sources as being the same or different. And so in this case, we have all of the images make up a photogrammic model. The hashes and the is generated using Preston software, and provenance tracking is also can be performed using Preston. And then it generates a data set that contains not only a DOI that can link back to the specimens, but also these hashes. And this work I've been doing with George Poland from Global Biotic Interactions. So how about a couple of examples? One example study that is using data sets generated from collections is our sampling of Santa Cruz Island, California. We are interested in what bees live there and how the island communities are different than the mainland, which is about 25 miles away. To understand this, we are using occupancy and detection modeling focused on the interactions between bees and plants as extracted from interaction records from natural history collections. We also resampled the island communities to develop a comprehensive checklist built in the bee library in Symbiota. And for the extended specimens, ideally, the published checklist, the opportunistic interaction data, and the resampling surveys would all link back to the original specimens. Another example, this is being led by Madeline Ostwald, a PhD, a postdoc with me at University of California, Santa Barbara. But we are building data sets of specimen traits to ask how these traits affect bee species' ability to respond to human-induced climate change. Body size and hairiness data sets are being created from museum specimens. Some of the indices of hairiness based on images of the specimens themselves. And the new data is collected from sampling, and the new data is collected from sampling the thermal tolerance of bees, newly collected bees. Combined, the trait information from specimens and the new assays may help us understand what factors are associated with the bee's tolerance to hot and cold conditions. In these cases, the traits may be generalized to species or have specimen level information. Either way, the resulting traits could be linked to the specimens used to create them. And then one final research example, and the lead investigator on this is Colleen Smith, a postdoc here at UC Santa Barbara, is using opportunistic data sets, again, of bee-plant interaction data, asking if we can predict bee floral specialization from these historic records. In short, the answer is yes, with up to 70% accuracy. For this question, we have two data sets, an expert list of specialist versus generalist bee floral resources, and again, the global bee interaction data set, which is an opportunistic data set indexed and taken from Global Biotic Interactions, which indexes museum specimens and the literature. Ultimately, a single specimen may be included in multiple data sets, and a data set could be used in many studies. A specimen can also gain value, potentially, from the number of data sets it belongs. And we could potentially track the impact of a single voucher specimen to science. So I'm sorry I couldn't be there in person, but please be in touch. Here are many of the references for some of the things and the publications that I showed throughout this presentation. And if there are questions, maybe one of my many collaborators are around in the room to help answer. Thank you very much.
All right, thank you to virtual Katja. And I'm going to just go right ahead and pass it over to Julie Ellen now. So Julie, hopefully you have permission to share your screen.
Okay, can you see that? Does that look okay?
Yeah, it looks great.
Okay, great. Thanks, Libby. All right, so today I would like to talk about a tool that we are building to kind of help increase the speed at which we get data from these specimens. So this is part of our DigiLeap project, which I'll talk about in just a minute, but I also just want to give a huge shout out here to all of these people that have been involved in building the Gazetteer that I'm going to talk about. So DigiLeap is an NSF-funded project where we are, pardon the dog, where we are working to increase the speed of digitization of museum specimens. And I just uploaded a talk about the first part of this process where we're working on building automated systems for collecting label data from specimens. And if you'd like to see that, that's loaded up on the wiki. And today what I want to talk about is locality data in particular. So information is one of the major gaps in specimen digitization. So often when we have a specimen, we have information that looks something similar to this. So this is a flea species, we have a host species here, and then we often have locality data that looks something like this: granite outcrops, sagebrush juniper, East Base granite mountain, Tooele County, Utah, at 4,500 feet, collected in 1966. So this is the locality data. And what we really need to do for that, of course, is take that information and place it on a map. Okay, and place it on a map. So and importantly, essentially what that means is someone who hopefully is familiar with Utah and Tooele County and can kind of go to a map and place that pin and get the information that's needed. So we can have a latitude and longitude for that specimen and use that specimen for research. Now, a best practice georeference has coordinates, so latitude and longitude, datum, so information about the coordinate system that's used, and some sort of level of uncertainty, generally a radius given for a circle around the point that indicates, you know, how certain the person was that created that georeference. So these three pieces of data are what's critical to have a full georeference. And this is, of course, the most missing information that I would say from specimens. So for example, a survey of herbarium sheets in SciNet found that 1/3 of the specimens are missing locality data and 2/3 are missing a full georeference. So they either don't have datum or they don't have uncertainty, etc. So this is probably the largest gap in data that we need. And it's partly because of the sort of time-consuming task of going to a map and placing a point there and getting datum and uncertainty, which does take a while. And there are automated processes, and that process, of course, is speeding up, which is really great. However, to date, there are millions of georeferences that have been checked and verified. So what we wanted to do is say, well, can we incorporate these into a global gazetteer by which localities can be checked against? So if somebody has already georeferenced sagebrush juniper outcrop Tooele County, Utah at 4,500 feet, right, and created a full georeference around that point, then we want to know that. So so each individual person doesn't have to go and georeference themselves. Okay, so why a global gazetteer? So why are we thinking about this? If we look at the data within GBIF alone, what we can see is, of course, there's been a rapid growth of data over time. And the vast majority of those have coordinates. So this is this purple grid here. And many of them only have country level information. And then the space between that, this yellow bit, are those that have no locality data. Unknown locality data. Now, what's interesting is the vast majority of these found in GBIF are, in fact, citizen science data, eBird, et cetera. So often those have coordinates that are very specific to being taken from a cell phone, for example. Now, if we zoom in to say, well, what about specimen data in GBIF alone? And in fact, if we break up GBIF data into just observations, this is eBird data, et cetera, we see, all of these have coordinates, for example. And if we look at specimens, however, we see a much larger disparity. So we have, with coordinates, of course, is this darker area here. Those with country only are found here, and then those without information. So we have a much larger gap in locality information of museum specimens. So it's really critical to find ways to start filling in some of those gaps. All right, and if we take a look at all the records, for example, we can see that here's the total number of points. Those with coordinates is pretty high, but those with a full georeference lag far behind the total records. All right, so what we did was first take a look at all of the specimens, or all of the records, pardon me, in GBIF. All right, and when we started, we had 1.6 billion records in GBIF. Those that were mappable, so those that have coordinates, were about 1.5 billion. And those that had coordinates and uncertainty, so they're actually mappable with some level of uncertainty, is 1.3 billion. Now, when we start moving all the way down into georeference, a full georeference, we can see that number shrinks quite a bit. So those with coordinates, uncertainty, and a datum, whether it's known or not, it drops all the way down to 330 million. And with an identifiable datum, we have 324 million. So this data set right here makes up the core of the gazetteer. These are the data points that have the appropriate level of information that we need for a full georeference. All right, so our goal is to take advantage of the georeferences that are already available, to add missing georeferences and improve the quality of other records. So first I'll go into the building process. So what we took all locations that are found in GBIF and all unique locations that are not found in GBIF that are found in iDigBio to make up the corpus of data that goes into the gazetteer. All right, and we took all of this information. So we took every piece of data that is associated with any record. So HG stands for higher geography. We have continent, country, etc., locality, string, any other information, verbatim coordinates, decimal coordinates, datum. So the coordinate system that's used, uncertainty, and any other metadata that was associated. Now, these three have check marks on them because these are, of course, the core of the georeferences. So for a record to go into the gazetteer, it needed to have at least these three pieces of information, and if more, the better. All right, so I won't go into this too much, but we did a lot of ingestion. We did a lot of standardizing and formatting of the data to get it into the gazetteer. We then selected records that removed some errors. So for example, uncertainty had to be had to be less than half the circumference of the Earth, for example. And so we removed some of those outliers in the data as well. Okay, and finally, we did some normalization. So the idea is that we have 3 different levels of data. So the first level are all of our georeferences that have the most information. The second level are those that have some information, and the third level are those that have the smallest amount of information. And the idea is that when we look up a reference, right, we first say, all right, if we have a locality string, run it past the georeference, how many coordinates have all of this information, right? Which would be the best result, right? Where we can match as many pieces of data as possible. If there is no match, then we go to the second best and to the third best, all right, to find a georeference that matches. Okay, so our georeferencer is called BELS, Biodiversity Enhanced Location Services. It is temporarily at localityservice.uc.r.appspot.com. And as of right now, you can input a file that has location information, give it an email address and an output file name, and you will be emailed the results. The code for BELS is found here on GitHub through the VertNet repo. And you can also put issues, questions, comments there as well, so that we can be aware of things that you all are seeing. And of course, the infrastructure relies on quite a few things that I won't go into too much here. So essentially, users can submit one or more Darwin core locations via CSV file. Those get checked against the BELS Gazetteer, provide an email address, and the results are provided back in a CSV file. The georeferences retrieved consist of Darwin core fields, so decimal latitude, decimal longitude, coordinate uncertainty meters, and geodetic datum. And of course, any other metadata fields as well. Okay, so what we wanted to do is say, all right, can we retrieve georeferences for locality data in GBIF that do not have georeferences? So how many ungeoreferenced locations can we improve? How many associated occurrence records can we improve? All right, so this is our use case. This was all GBIF data that is not georeferenced. We ran this through the Gazetteer and then asked how many gave us this best result, etc. And just a quick highlight of these results. So we had 1.6 billion occurrences in the first place. 32 million of those were georeferenced. Of those that were not georeferenced, we were able to add 59.6 million georeferences. So over double the amount of georeferences that currently exist in GBIF. And this is pretty exciting because this means that is 59.6 million records, occurrences that do not have to be georeferenced. Now, when we zoom into specimens only, we have a total of 270 million specimens. 27 million of those were georeferenced, and we were able to add 16.6 million by running the remainder through BELS, which again is very exciting because this is quite a bit of work that then doesn't need to be done. I want to talk about one quick validation study that we did. This is a hand-curated set of horseshoe bats. This was done through collaborators at Yale, where each of these data points was validated and hand-curated. And what we did was take all of those locality data information, run it through BELS, and then asked from the georeferences that occur that we get out of BELS, how many of those match the hand-curated data set? We found 1,700 georeferences in the Gazetteer that matched. 78% of those overlapped within the buffer radii. So first we asked how many points were dead on, like with the latitude and longitude were identical, and about 107 of those. But what's neat is the vast majority of those, the points were within the uncertainty radius of the original georeference. So that gives us a lot of confidence that the output from the Gazetteer can be used and reused across data sets for research purposes. Okay, so the next steps, we are incorporating new georeferences all the time. We just updated it with the 2.2 billion now that are data that are in GBIF. We have an API, we're improving that, bulk processing, and of course, we're going to develop a user interface. And importantly, what I want to point out is what we're working on this fall and over the next spring is in integration with other services. So we are going to integrate BELS with Geolocate and with Symbiota. And the idea here is that a user could have a series of records, push it through Geolocate, and then say, first run it through BELS to see how many georeferences you get, and then the rest run through geolocate and go ahead and do those georeferences. So this will be a user decision point, and Symbiota as well. So the idea is to get this tool incorporated into as many services as we can so that it can be really helpful and useful for the community. All right, and we have a number of kind of steps down the road, including some fuzzy matching, et cetera, that we're working on. And we certainly would love to hear from all of you about improvements that we could do. All right, so with that, I'll just leave the website up here again. This is what the interface looks like, and say thank you very much. In particular, thank you to John Wachorek, who has done just a tremendous amount of work building this service, and I'll look forward to questions. Thank you.
Wow, that's phenomenal, Julie. Thanks so much for sharing. There are a couple of questions in the Q&A. Julie, feel free to answer them there, although I think they might be discussion worthy as well. So maybe we could revisit those too after we get through the next couple of talks. So thank you. And next up, we have Abby Benson. Abby, thanks so much for joining us. And you should be able to share your screen.
Great, thank you. How does it look?
Perfect.
Awesome, thanks. Okay, so what I'm going to talk to you about today is how we can keep all the data together. My name is Abby Benson. I work for the U.S. Geological Survey. I'm the node manager for GBIF US and OBIS USA. And so I'm hoping what you'll get from this talk is the rationale for what's called Event Core with Extended Measurement or FACS. Provide you some use case examples so you can kind of see what is included by using this extension to Darwin Core, and then some formattings in case you want to try to format it yourself. You'll see a way to do that. So what was happening for OBIS, and the reason they embarked on this, was that when we received data, and I don't know how many of you have this kind of data that comes to you, but there was a lot of data, not only measurements of biotic measurements that, fish lengths, abundances, things like that, but there are also a lot of abiotic measurements. So things like temperature, salinity, wind direction, barometric pressure. And when we were formatting the data using Darwin Core and sharing it to OBIS, these things were getting truncated out. So they were basically just being left out. And we wanted to make sure they were included because they're really important pieces of information from the collecting survey. So I've applied this to a few examples that I'm going to show you here and give you a sense of what you can include using this extension. So the first is with the Sanctuaries Marine Biodiversity Observation Network. When we're doing occurrence only, you're able to say there was a blue grunt, it was in the Florida Keys, and that it was at a particular depth. So that's really all you can do with occurrence only, no extensions. So with the Event Core with Extended Measurement or FACT, you can say there is a blue grunt, it was in the Florida Keys at a particular depth, so all those things. You can also have the abundance of the blue grunt, fish lengths, and the underwater visibility in meters. So that one in particular, the underwater visibility in meters, is what would have not been included previously. Another example is from the USGS Great Lakes Trawl Survey. So for this one, we saw a yellow perch in the Great Lakes. There were 33 adults, and that's all we can do with occurrence only. If we use Event Core with Extended Measurement or FACT, we know there were yellow perch in the Great Lakes. There's 33 adults. We also know the temperature of the lakes where the gear was deployed. We can have the fish lengths and the weight of those 33 adults. So we're able to include all of that information and make sure it stays together. What this looks like is there are 3 files. There's an Event Core file, an occurrence extension, and then an extended measurement or FACT extension. In this sort of view, the extended measurement or FACT file is split in a way, so you can kind of see where you would link things off of. So the Event Core file would tell you information about the collecting event. So the cruise, station, it'll have like latitude and longitude, depth, all those geolocation information that Julie was just talking about would go into that file. the occurrence extension would have information about the organisms you observed. And then in the extended measurement or fact extension, we can include things like biomass, abundance. So these are measurements of the occurrences, but also measurements or facts about the event, like device type, surface area, grain size, temperature, salinity, those types of measurements. So to give you a sense of what these files look like, this is from the OBIS website. If you want to take a look, this is a macroalgal example. So here we have the event file where you have information about the event. Then we have the occurrence file where you're seeing information about the organisms you observed. And then finally, the measurement or fact file has measurements that relate to the events like shore height or surface area, and then also measurements that relate to the occurrences like percent cover, or here it's called cover, length, functional group, things like that. Oh, length actually is the length of the track, so that's about the event. But one other thing that OBIS implemented with this extension is to include a place for URIs, so that when if you call, like if we called it measurement type cover, or someone else calls it percent cover, or you have a capital C, or all these different various ways of saying percent cover, if you're using this URI and everyone's using it consistently, then you don't have to worry about what the type is called. You can just use these URIs to find the measurements you're looking for. And OBIS has this sort of reporting feature now. We've got plenty of measurements in, and so we're able to start sort of looking across data sets to see what kind of measurements there are. So here I'm just showing searching for abundance in the measurement types, and we can see how people might write it a bit differently. But when we use the type IDs, we know, okay, if it's all the same type ID, we know it's the same whether the A is capital or not. This is the same measurement type. So at this point, we have over 185 million measurements or facts in OBIS. So we've been collecting quite a few of them, getting them in for data sets. And this is accessible right now. You can go and get these measurements out of OBIS using the R-OBIS package. So here I'm showing we're going and accessing that USGS Great Lakes Science Center data set, pulling it back from OBIS. We're saying we want the measurements or facts to come back, and then showing you, here we have fish length, total weight of fish caught, and temperature at depth of gear deployment. So, we're able to include all of these measurements, and you're able to access them back out of OBIS. So kind of ran through that pretty quickly, but hopefully you have a sense of why OBIS decided to create the event core with extended measurement or facts. It's sometimes called OBIS-EMF data, and that it's keeping all the data together so we don't have to drop out any sorts of measurements when we're sharing. The format requires 3 tables that are linked together. You're able to include abiotic and biotic measurements, and this is all accessible via our OBIS if you'd like to get to it. So that's it from me.
Thanks, Abby. I always like hearing from the ocean side of things. I feel like some of those variables are things that we're not always discussing in these discussions. So I appreciate it. Thank you.
Thanks.
And I believe I'm passing it over to Ed Gilbert next. Is that right, Ed? You're going to be doing this one.
That is correct.
Super. I'll let you take it away.
Share my screen. All right, I'm going to present on work that we're doing to expand the interoperability of Symbiota and the goals improving the community connectivity within the Symbiota community and beyond. So Symbiota is an open source software that's available within GitHub, and it's generally used to create occurrence-based biodiversity portals. Sometimes you call them virtual floras, virtual faunas, specimens tend to be the core data behind a portal, definitely occurrence data, but biologic inventories can be defined within them, identification keys, also taxonomic hierarchies, field images, distribution maps, taxonomic descriptions. By itself, Symbiota doesn't have any data associated with it. It's just software. You download it, and whatever project downloads it, they modify the configuration files and CSS files, give it a particular look and feel. And then they load the data, and generally the data and the design of the portal represents a certain taxonomic or geographic scope, which represents the community that defined the portal. So the portals have a particular theme associated with them. And it's the folks behind the portal, the experts, that are the ones that manage it and drive it. And so each of these portals are a community within itself. This is an example of North American lichen herbaria, but it's expanding to the lichens of the world. This is a portal that's dedicated to live managing arthropod collections. And then here's a portal dedicated to vertebrate collections. This is a country-based portal, so it's collections associated with Gabon, the country. Another country-based portal, so this is collections associated with collections from Panama. Now, there's a number of these TCN biodiversity portals, or a number of these Symbiota portals that are associated directly with TCN initiatives. And some of the TCNs are using the portals to support digitization, such as batch georeferencing, duplicate harvesting. So if you have a specimen where a locality or a duplicate specimen duplicate was digitized in another collection, you could easily import that in and reduce the time for data entry. Also, data cleaning, data quality checks. There's usually help desks and training and outreach associated with each of these portals. And then these portals are also being used by certain TCNs to define extended specimen relationships, such as specimen associations, image tagging. The CCH portal is using their portal to record phenology, and that information gets exported within Darwin Core, within measurement or facts extension. Another important role that these portals serves is they assist in publishing the data up to GBIF and iDigBio. And a final rather important role is that it provides an interface where these digitization support and tools could continue after the end of the funding cycle of that TCN. So it could be an ongoing thing that's offered to the community. So there has been some web services that have been integrated into Symbiota for several years now. Some of these are, there's a Darwin Core archive publishing tool where it'll dynamically package up a Darwin Core archive based on a RESTful API call. And you could have certain variables in that call that will filter based on Darwin Core terms. And so that's used for streaming data out. And then there's some web services that interact with geolocate. So a collection manager can push a data set out to geolocate community tools. The community could georeference the specimens within that interface, and then the coordinates stream back through the web services into the records as they're being georeferenced. And then there's a web service where you could push data into a Symbiota portal, and Specify uses this to push a snapshot of their data into a portal. So these tools have been available. They're part of the first version of the API. However, we're redesigning the API and building version 2. And we're using Lumen by Laravel. It's a PHP framework to build the API, and Swagger for the documentation. And the goals is to create a more robust API with good documentation, so it's easier for developers to figure out what calls are available, what endpoints are available, and integrate it into their external applications. And then we also want to improve data flow between these portals. Here's an example of the interface, the Swagger interface for exploring the API calls that are available. And it has a nice user interface where developers could try the calls out, and it gives you a formatting and all the variables and required fields for each of the API calls. So now I'm going to give a little demonstration of Symbiota environment. So the multiple portals, so the Symbiota community, and talk about a little bit about the data flow that happens between these portals. So each of these squares here represent a Symbiota portal. So this is the Panama portal, all taxa from Panama. The square in the bottom left, that's the consortium of New England herbaria, vascular plants. And then the square to the bottom right there, that's SciNet. So it's vascular plants of North America. And the green little dots represent collections that are within these portals and being managed as live data sets directly within the portal. So the portal user interface represents their live database. So if a record's changed, it's immediately represented within that portal. However, most portals also contain snapshot data sets. And that's data that's imported from another application, another data management tool, maybe Specify, EMU, or an IPT. And that's the data that supplies information for duplicate harvesting. So it gives support to those live managed collections for digitization efforts. And then some portals might just be all snapshots. And that's true for COTRAM, which is a portal dedicated to American Myrtaceae. It's a plant family. And but also the Big B portal, that's a TCN portal, that is mostly just live collections. And they use that portal to define certain extended specimen relationships and tagging images and species associations. So by themselves, these portals have their own backend database, and there's no data flowing back and forth between the databases. They're all separate databases. So in that sense, they're kind of isolated islands of data. So they all function as a mid-level aggregator. However, we do have that Darwin core archive publishing tool there. And for years now, we've been using this to push data from one portal to the other. For instance, Arizona Vascular Herbarium, they manage data within SciNet as a live collection. And they use that tool to publish a snapshot of their data from the live collection into the Panama portal as a data snapshot. And then the Myrtaceae portal up to the Myrtaceae, American Myrtaceae data. And this infrastructure is used to push data throughout the Symbiota network. But it's also the same tools that are used to push data up to GBEF and push data up to iDigBio. Now, what we're working on is to extending the API infrastructure. And we're also working on extending the provenance of data flowing back and forth between the Symbiota portals. So live collection can know all the snapshot records where they've been pushed out to, and vice versa from the snapshot collection, they know where the data came from. And we're designing it so that instead of doing data packages being pushed up to these different portals, that's still supported. But once it's pushed up, we want to have a system where if someone annotates a live collection within the Arizona State Vascular Herbarium, that annotation, that modification could flow up to all the snapshots in real time. So now we have a situation where the snapshot records are synchronized with the live collection records. And now we don't run into problems of having to maintain those updates, and the distinction between live and snapshot records falls away. And it's rather than periodically having to update these full records, these full record data sets, we're just doing it record by record, so there's less work involved. And we also want to have it set up where someone can do edits within a snapshot collection within another data portal, maybe the Big B portal. And then the collection manager can pull up and say, okay, what edits have been done and what modifications can I pull into my central database? So we want data to flow in both directions. And we want this to happen throughout the Symbiota network. And the idea is once we could test this concept as a working concept and get it work in a robust manner, perhaps we could expand it and have data flow throughout the whole external network too. And all this work is being done as a team effort with the Symbiota Support Hub team. And here's a list of all the members. And that's all I have for you.
Great, thanks, Ed. Yeah, as you pointed out, so many TCNs are working with Symbiota, so I have no doubt that this will be really relevant to them. I think I'm going to turn it now maybe back to Julie. Julie, thank you for answering questions in the Q&A there. And if you are able to maybe just follow up with one additional question. I see that Jorrit asks, how can he copy or cite bells to reproduce your results?
Great. So as of right now, Bells is not able to be downloaded, but we do version control it, so you can determine which version you got it from. Therefore, and in that information includes, of course, what data was pulled from GBIF and from iDigBio. We do have the API that's functional, but as of right now, there's not a standalone version of Bells.
Thank you.
Yeah.
And maybe I'll put Katie on the spot. Katie Pearson, I see your comment in response to Abby's presentation about measurement effect for phenology. And I don't know if you have any more, if there's a question in there, Katie, or Abby, if you have any more information kind of about that type of application.
I don't know if there's really a question there. It's just like, oh, good, someone else is using it for traits, because we're going to try to link it to traits too. At least that's the plan.
Mm-hmm.
Yeah, and that should, do you guys have a like an ontology or vocabulary for URIs that you're thinking for using for traits?
Yeah, fortunately, there was a plant phenology ontology developed a couple of years back that we helped with, and we're just like, oh, sweet, we have the vocabulary, let's try to slot it in there.
Yeah, nice. Libby, can I ask Julie a question?
Please, yeah.
Okay, great. Libby, Julie, I was curious if Bells works for marine places, and is it global? Did I miss that, or is it like US focused?
No, it's global. So anything that was in GBIF or iDigBio have been incorporated into the Gazetteer, and that does in fact include marine. We do have loads of freshwater and saltwater fish, for example, in the Gazetteer.
Awesome.
Yeah,
That's great. Yay.
Yeah, the idea is for it to be completely comprehensive. And I had one question in the Q&A that I just kind of want to mention. And someone asked about getting data into Bells. And I just want to point out that we are regularly pulling data from GBIF and iDigBio. So every time we download a new data set, we reversion Bells. And so if your data is going into GBIF or iDigBio, that should be ultimately incorporated into the Gazetteer. So the Gazetteer, of course, will grow over time as those data sets grow as well.
Awesome. I'm going to put, and we have a few minutes still here, guys. So if anybody in the audience wants to put a question in the Q&A, or if panelists here want to ask questions of each other, lots of time for that. I'm going to maybe jump off into a question that anybody here can answer. Because listening to the talks, it kind of dawned on me that, I think you guys all did all these are the work that you're describing is kind of represents work getting through hurdles or obstacles that sort of exist. And so I'm wondering kind of, and then, with these fantastic results and really pushing the field forward to be able to have more access to data, to link data, to improve data quality, all of this kind of stuff. I'm wondering if there's sort of like if you had a magic wand and could fix any of these obstacles, and what would it take to bring your research, to bring your work, to bring some of what you described to a really transformative next level? What would that take? What would that, like, what wand, where would you wave that wand? And it could be, this, it's a pretty obviously, silly question, so you could take it in any direction you like, but yeah, how would that be useful to you, and how so?
I would say that everything got a stable, resolvable GUID, and everything being occurrence, every measurement, anything that happens to a specimen gets a GUID, and then there's a place to store that and connect it. Right now, like, we're making a lot of GUIDs, and we're kind of trying to connect a lot of GUIDs, and it's working on some level, but then there are just other things where you're like, yeah, and that one just disappeared, and we have no idea where it came from.
Right. Yeah.
GUID being global unique identifier.
Thank you. Yeah. Yeah. Anybody else? What would it take to sort of like next level your work? If it's as easy as that.
Trying to think. It's a hard question. Because I think the magic wand I would wave, I guess, as a node manager, is that all data is just following Darwin core.
Yeah.
Then it would just go in to the places I'm trying to get data shared to. So
yeah.
I would like to get the collections more involved. And I mean, it's a real mixed bag. And there's multiple reasons for that. There's a lot of times there's not a lot of funding, so there's a lot of collections that are working on a shoestring, or they don't have someone dedicated to that because the institution doesn't really see that as a main priority. And or if they get someone on board, they're on board for a little while. They're learning what's involved in managing a collections and within the community. Then they disappear. Then you get someone else on board. And so I think that's a real weak link. And I don't know what the solution for that is. More money for the collections or what?
I second that. I would say if we could have a community of skilled data managers that were funded, that's always the problem, is we have a lot of skilled data managers out there, but they're hopping from job to job. But we need more people who can help us curate the data, because specimen curators are not always willing or able or have the time to do data curation too. So those are two different jobs, and they can sometimes fall on one person, but that's not always optimal.
Yeah, I think it's interesting that the points you guys raise are things that seem doable, or seem like, well, we could do. It wasn't just kind of like it wasn't like a crazy moonshot type of idea, which gives me some hope that we can make some progress with some of that, hopefully. Yeah. Oh, that's cool.
And I feel like we are making progress. I mean, as a community effort, I think we're far more connected as a community than we ever have been. And I think that is improving. And I like being a part of it.
Yeah, and I think, what this BioDigiCon conference has shown, and, if we go back 10 years, is kind of like the precursor to some of these things, like the IDBio summits and all this kind of stuff. If we were to sort of snapshot some of those discussions and conversations about Darwin Core, about identifiers, about building the community, I think we would see that right now we are in a much stronger place than we were on all of those fronts than even 10 years ago. And if you go 10 years before that and so on and so forth, like it does seem like, now that we have so much more in place, socially, technically, all of this kind of stuff, that, the next 10 years looks promising too. Yeah. I've noticed some discussion in the chat. I'm not sure, but I haven't been able to follow up with it. If anybody wants, on the panel wants to call anything out, or if anybody from the audience would like their mic opened up to discuss more of this. We have just about 4 minutes left here.
VJ mentioned the importance of getting Darwin Core and Abby agrees data management into lower educational levels so that they will then trickle up.
Sorry, go ahead, Katie. I'm sorry, I didn't mean
I was just going to say, Livy's done a lot of that with, I forget what it's called. You have to tell me, Livy.
With Blue, you mean, or?
With Blue, yes.
Yep. Yeah.
Cool, because what I would love is to never see a spreadsheet color-coded ever again. If I could just never have that happen. That would be excellent.
Red for species, orange for locality.
Yeah, and the discussion I had this summer was that somehow someone's teaching undergraduates that this is a thing, you don't just magically know to color code your spreadsheet. So where is that coming from, and how do we stop it? That would be great.
Yeah, no, I love that. And I think it kind of makes me think too of something that Kat said in that session a couple of hours ago, which is that, like, a lot of us are starting at square one. Like when we came into this, we had to sort of start at square one. And I think for many of us, it was a little bit of a circuitous route to even find that square one. It's not that like we learned about Darwin Core day one of like Bio 101 in undergrad or whatever. It was, maybe further on down the line after you're maybe in grad school, if not in a career, in whatever position you're in. And then, hopefully you learn about it in a way that you could then apply to your research and all this other kind of stuff. But oftentimes it's like self-taught. It's like a little of this, a little of that, a little wacky. And then, you find your people and hopefully things progress a little further. But I think, we can probably improve some of how that education is happening to improve that kind of like workforce development and even that community building that you were talking about, Ed, too. So yeah, it's interesting. Ooh, scented spreadsheets. Now you're talking. Yeah. Just multi-sensory, like all the things. Yeah. Totally. And some of them do link to audio files too. So I think really multi-sensory is where it's at. That's the next level. Yeah. Oh, okay. Yeah. And JT Miller here wants just one giant Excel sheet. I can't wait to see that. Yes. Crash everybody's computer like day one and create all sorts of interesting problems. Yeah. All right. With just a minute left here, I will kind of wrap us up, and I want to give a huge thank you again to our speakers today and to our audience members and to David and Lauren and Kat and Gil and Jill and the ASICS folks. Why can't I talk at the end of the day here? It's been a long one, who have been keeping this churning in a hurricane. So, and Floridians, please do stay safe.